I will now proceed with a graphical explanation of what we just found to solidify some of these ideas. So let us attempt to graph this a little bit, not not terribly precisely, but just a rough sketch. Alright, so we have x squared minus e to the x to the left of 0. So to the left of 0, to the left of 0 here, the curve should look like that. So that curve's not so obvious. What does it look like? But nevertheless, we know that as x approaches 0 from the left, we saw that the limit was heading towards -1. So we can at least plot that, and I'll extrapolate a little bit more in just one second. Let's make that right here. So there's a hole at -1 as we approach from the left. So the function must be heading towards that location as x heads towards 0 from the left. So there we're heading towards that. So now I'm going to, as I said, extrapolate just a little bit. Not too precise, but x squared minus e to the x. E to the x to the left of 0 is not that large of a number, because to the left of 0 it's the reciprocal, right? X would be negative, so therefore you're actually taking the reciprocal. It's like 1 over e. So it's pretty small, and x squared would kind of dominate that this difference here, and x squared is positive. So x squared minus this little bit will still kind of look like x squared, and the further out to the left you go, I can guarantee you it's going to look more and more like x squared. So not only that, I can also tell just by looking that this rule here is yielding a decreasing function to the left of 0. So in other words, it should look something like x squared heading down here, right? It's not quite x squared. It's x squared minus a small little bit, a small e to the x values. Nevertheless, it'll look pretty much like x squared heading down towards that hole, right? Always decreasing down here towards that hole. All right, so that's what's happening on the left. On the right, we saw that it was x minus 1. So x minus 1 is easy enough for us to plot, right? A linear function. So here it is. Y-intercept is -1, and we know it just has a slope of 1, so it should look something like this. Okay, so there's f of x. Again, just a rough sketch to give an idea what's going on. And we know that as x approaches 0, x approaches 0 from the right, that the function must head towards this -1 value, because that's why the limit existed, because the two one-sided limits were the same, both here at -1. But what was the function value? Because right now it's discontinuous. Well, the function value itself was also -1, is what we saw, right? F of 0, the function value at 0 was -1. So therefore this is actually filled in, and so we see that the graph is continuous there. i.e., we have a totally connected graph with no breaks or holes.